In notes 27, we're going to discuss correlation coefficient. The definition of correlation coefficient, which is the R, is a measure of how well the data set fits a linear model, or in other words, how well it makes a positive or negative straight line. So the R is a value in the range of where it's greater than or equal to -1 and less than or equal to 1, which means basically R can be between or equal to -1 and +1. So here's some examples that you need to see. So if this right here, this has a like the line of best fit, what you were talking about in lesson or notes 26. If it has a negative slant, then it's going to have a negative slope. And the closer the points are to each other, the stronger the correlation. So this one says very close to being a line, has a strong negative grouping. So anywhere from a negative 0.8 to a negative 0.1. And then on this next one right here, your correlation coefficient R would be about a negative 0.6. It's kind of going in a downward, so you can kind of draw a line of best fit through that data. From left to right, has a weak negative grouping, so that means the points are spread out a little bit more. And then this one is 0 right here, because you don't know if you need to draw your line this way or positively, or should we draw a line of best fit going negative. So that's why it's very scattered. There's no positive or negative trend. And then on this next one right here, we can draw a line of best fit about through there. So we know it's going to be a positive correlation, but again, the points are spread out a little bit, so it's going to be more of a weak positive. And then this one is the points are pretty close together. That's probably not the best line of best fit, but we can adjust it there. So the points are real close to the line, so it's going to be a strong grouping. So it can be anywhere from 0.8 to 1.0. All right, so it says on problems 1 through 5, for each scatter plot, tell whether the correlation coefficient R is closest to, and you've got a negative 0.95, a negative 0.8, 0.2, 0.8, or 0.95. So go ahead and pause this right now and then just kind of decide which one it's going to be. All right, so this one, see how the points are pretty close together there? So this is, and it's going to negative slant. So this would be a negative 0.95. So we've done that one. And this one here, it's going to be positive. They're kind of spread out, but not too bad. So it's going to be a positive 0.8. And then number 3, they're real close together. Okay, so this is going to have a positive correlation, and it's going to be close to 1. So it's going to be the 0.95. Number 4, it's kind of hard to tell a little bit, but I do think because of this outlier point out there, that it would be more like this, but it's real close to 0. But we're going to say that it's a 0.2. And then, of course, this one is your negative, and they're spread out just a little bit. So this would be a negative 0.8. So I hope that helps you in determining the positive and negative correlation, and also the closer the points are to the line of best fit, the stronger the correlation. And so that would either be to a -1 or to a +1. All right, so what we're going to do here is we're going to draw a line that best fits this data. If I can get my little box back here. Where'd it go? All right, so we're going to draw, so we're going to be somewhere. You want half the amount of points. So we'll see how this one does. Something like that. That may not be the best, but we'll give it a shot here. Alrighty, so we've got, I don't want the webcam. Oh, and I can't seem to get my, there we go. Okay, hang on. There we go. Okay, so now I'm going to erase a few of these marks that I just put on here. So I drew the line that best fits the data and says, what do you think the correlation coefficient is close to? It's almost like it could be a 0.8 because there's like a few of these points right here that are close to the line, but then you have a few of these out here, that are kind of far. So it's almost like it would be maybe a point, I don't know, 7, 8 or 9 or something like that, somewhere around in there. Okay, so now what we're going to do is we're going to get the calculator to help us out. So it says now put the data in the calculator. So this is the information here that you need to take the time right now. You need to pause this and you need to get your calculator and go ahead and do what it says. Go to list and spreadsheets, arrow up to the top of column A. We're going to, instead of putting an X, we're going to rename it hours. Then go over to column B and rename it grade. Enter the data in the appropriate columns. And so here is the data right here from the table of values. Go to menu. This should say menu, not mu. Choose 4 stats, 1 stat calculations, then 3 linear regression mx plus b. Click the arrow to choose hours for X list. Tab, then choose a grade for any list. All right, so we found out that the slope was going to be 6.88372. And then the B, the y-intercept is, boy, I'm way off on my line, 44.6346. So if you look at the y-intercept, I'm below 40. That's almost like at 20, 30, 35. Wait, 25, 30, 35. So I was really off. I needed to go up a little bit higher on my line of best fit. Now, it shows you R squared. We are never going to use R squared in Algebra 1. Now then, the correlation coefficient, the R, ooh, that's a little bit higher than what I had thought, is 0.851409. And really, we just round it to the nearest hundred, so it'd be 0.85. So then let's go down and let's see what else it has to say about this problem. So it says, is the correlation coefficient a strong, so is the correlation coefficient 0.85 a strong or weak correlation? Well, it's going to be fairly strong. And then number 4 says, write the equation, the line of best fit in slope-intercept form. Round to the nearest whole number. So it's going to be y is equal to, our slope is 6.8. So we're going to round that to 7. And then our y-intercept is 44.6. So we're going to round that to 45. All right, so I hope that helped with this.